of becoming the senator. Rather, what he's faced with is what's called a lottery over outcome X, which is becoming senator, and outcome Z, which is being out of office, because he could lose the election. Okay, he was running against I think it was Ted Kennedy at the time. Yeah, it was his most preferred and least, and so these two are his most preferred and least preferred outcomes. So he's left with a choice: should I run for governor? Right. If I do, I'm relatively certain of becoming governor, right? But that's my second most preferred outcome. Remember my preference or his preference ordering from the last slide. If I run for senator, then I'm not sure if I'm going to become senator or if I'm going to actually be left out of office. Okay, so what does he do? As I said, so he has a choice between almost certainly becoming the governor, outcome Y, and a lottery given roughly even odds of winning the Senate seat and being left out of politics. So what would you do? How does a person decide under conditions of uncertainty what behavior to take? So here, we're playing under conditions of uncertainty because we're not sure whether Weld himself isn't sure whether he's going to win the election or not. So this is where what's called the maximization paradigm fits in. Okay. So what is the maximization paradigm? Well, rationality is associated with the capacity to order and an aptitude to choose from a set of alternatives in a particular manner. How do we decide to choose? And this goes back to choosing in a consistent manner from a couple of slides ago. Well, we typically choose as a means of pursuing some goal or objective, aiming to do the best that we can, okay, given the circumstances. And this is the crux of the maximization problem. So, and we all act to maximize something that is of value. For instance, elected politicians maximize their votes during an election. Basketball players maximize the points that they score on a given shot. Okay, maximization under conditions of certainty is very easy. Okay, for instance, what if you knew every time every time you stepped inside the 3-point line that you were going to get the ball in, and if you stepped outside the 3-point line that you're 50% certain of getting the shot in. Well, it's kind of easy. I mean, you would shoot from inside the 3-point line all the time because you're certain. But as is the case in basketball and most things in life, we're dealing with conditions of uncertainty, as was Governor Weld. Okay, now. So because you don't choose, right, outcomes directly, as I said, Weld could not choose to become senator. He had to choose. His only choice was to run for Senate or not. Okay, so you choose the instrument that affects what outcome. So as I said, Weld couldn't choose to be senator. All he could do was choose to run for that office. Okay, so based on that, we see that a rational individual chooses the instrument, and here the instrument is running for office, that she believes will lead to the best outcome. Okay, so a belief is in this sort of instrumental view of rationality, a belief then is a probability statement which relates the effectiveness of a specific action or instrument for various outcomes. What does that mean? Well, there are three types of belief. So certainty, going back, so we're highly confident that a specific action will lead to the desired result. So in the Weld case, he is very highly confident that running for governor, he will be reelected. Okay, he will receive outcome Y. Risk. Now, risk. Remember that before in a few slides before I said there was certainty and uncertainty. Well, uncertainty can actually be unpacked into two different types. Risk is different from uncertainty. Risk means that the person isn't certain of the outcome, but has a fairly clear idea of the probabilities associated with that action. So this is the situation of Weld running for Senate. He runs for Senate under a condition of risk. In other words, he has, given polling data and other sort of data that he has, is fairly certain that the odds of winning the election are about 50%. So he has just as good a chance of winning as of losing. So anytime you have a fairly good idea of the probability that a certain action will lead to an outcome, okay, then you're dealing under conditions of risk. Okay, and this is good. Uncertainty in this sense has a little bit of a different meaning than risk. What it means is that you absolutely have absolutely no idea or very little precision about the probabilities linking actions with outcomes. So You have no idea. So you can't even think about the probability that this action or this behavior will lead to the outcome. Okay, so oftentimes we have we generally are dealing in situations of risk where we have some kind of idea about the probabilities of actions, the link between actions and outcomes. Okay, so when there's certainty, right, rational behavior is easy, as I said before. You just pick the action or the instrument that leads to your top-ranked alternative. Okay. For instance, let's assume, going back to Weld's example, if Weld were certain rather, that he is generally certain that he's going to be the governor. So he knows what his preference is there. His preference of being governor is second highest. Now, if he were certain that by running for senator he would become senator, well, then it would be easy, right? Because he would simply then run for senator, because that is his top-ranked alternative. Unfortunately, right, he's not certain. So we're dealing with a situation in which the action-outcome relationship is more complex as a result of risk. Okay, so the principle of rational behavior then becomes a little bit more complex. Okay, so under conditions of risk then, okay, which is what we're dealing with in the Weld case, the decision maker needs to basically assign a numerical value to each outcome, which is called the utility number. So he has to assign a numerical value to, how much value does he place in being governor versus being a senator versus being left out of office. Okay, so so we can sort of describe those as the utility number for each of these outcomes as the utility of X, utility of Y, and utility of Z. The assignment of course, utility numbers depends on relative values placed on outcomes. Okay, it doesn't have to be cardinal. So if an assignment of utility numbers is, let's assume that these are the values that Weld places on the various outcomes is this. So in other words, the utility of becoming senator is 1, the utility of being the governor again is 0.2, and the utility of remaining out of politics is 0. So in other words, what you're saying essentially is that the value of becoming a senator to him is about 5 times what it is of being governor again. Okay. So now we have quantified preferences, and we've moved sort of from ordered preferences to what are called cardinal or numerical preferences. Okay. Now let's incorporate beliefs. So beliefs, remember, preferences are about the internal world. Our values, our beliefs, our values, our desires, and our wants, whereas beliefs are about the external world. And so the external world is about or incorporating risk. Okay, so for each action or instrument, our belief is the probability that it will lead to one of the final outcomes. Okay, so in the Well example above, right, we know that action A, running for Senate, led to a 50-50 chance of X or Z. Remember, 50-50 chance. In other words, he could have 50% chance of winning the Senate seat, X, or remaining out of politics, right? So that is, once again, a little bit of algebra. The probability of behavior A, action A, which is running for Senate, leading to X, which is winning the Senate seat, is a half. The probability of running for Senate leading to governor is 0, right? Because you can't win the governorship if you're running for Senate. And the probability of running for governor and being left out of office is also a half, right?